Yo, I'm River, and I was kind of disappointed when these were all not going to be about me, but where I'm going to take you is the next best thing. I first want to point out that we are learning, exploring, and playing on the traditional and ancestral lands of the Songhees people. Let's listen to some music to get started. Bam! Now we're at the base of Mount Doug, and we're just about to go explore Douglas Creek. Now, Douglas Creek gets its water from groundwater and underground watersheds and reservoirs.
This is where we'll be going, the light blue stream, Douglas Creek.
We're now at Douglas Creek. Now this watershed, it used to be all forest, but now it is mostly farmed because of the last 140 years of development. And now, in that process of converting forest to farm, there's only about around 1.1 kilometers of stream left, and here it is. Oh, hello there. I was just admiring this scenery, and I found that where we are in Victoria, BC, and especially at Douglas Creek, we are in a CSB, or Mediterranean climate. Okay, so we can see that the precipitation of Mount Doug really does affect how much sediment and how much water is moving through Douglas Creek. We know that in a Mediterranean or CSB climate, it precipitates a lot here. That also really has to do with the depth and sediment transport of Douglas Creek. One thing I find really interesting about Douglas Creek is the natural diversity here. Even though it is surrounded by much development, it still keeps the whole natural ecosystem alive and healthy and well. We can see that the topography near and around Douglas Creek is quite steep. We're at sea level right now, but Douglas Mountain, which is very close, is at 225 meters of elevation. We can also see that the stream current and discharge is very dependent on the gradient of the stream. We see here very, very low gradient, moving slow, currents very, very weak. Now, we get to a little bit of a steeper slope as it gets closer to the ocean, and it goes faster, it's moving faster, and we can also see that this is the case because we have bigger sediment at the bottom here, meaning that the sediment would have had to move and is displaced here instead of here where mostly the bottom is clay and smaller pieces of material. You can also see that because of what I mentioned earlier about the sediment and the precipitation and the whole climate in general, this is a meandering stream. We know this because you can see the current. It's not grading around different rocks. It's not bringing a lot of sediment like an incising stream. This is wide, it's snake-like, it curves but doesn't curve around little things. This is why Mount Douglas Creek is a meandering stream. So one really interesting thing about Douglas Creek is it has a natural levee. So this means that a levee, artificial or natural, in our case natural, stops or limits the flow of water. We can see here, it does do a lot to the form of the river in that the width gets wider and wider as the water is limited in its places to go. This levee also has a big impact on eddies, which we see over here. An eddy is a place, like in kayaking, where the water stops and does a whirlpool effect. We can see one here, a little one, stopping at the levee, going round and round, and as we see the bubbles go into the eddy, do a nice little whirlpool, and come back out. One here, one right over there, and one here. These also have a very big effect on the function of the river, in that water will move in circles rather than keep going straight. This will have deposit of sediment in the middle of these whirlpools usually, where the current is very limited or lower. And in our case, we find a levee and eddy very close to each other. These both make a lot of sense because the levees lower the current and reduce the flow of water, and an eddy is a spot of the water that turns and turns due to the lack of flow either in depth, but in our case, limit of water flow out of the circle at the mouth of Douglas Creek. Another really interesting feature about Douglas Creek is the floodplains. We can see this here of the wave movement and we can see how it deposited sediment here. As we move further up the creek, we also notice the sediment buildup on the corner here. This is due to high levels of precipitation, and when that happens, bigger deposit is left on the floodplain. This is really great to see when the creek is low levels like it is right now, because we can see the floodplain visible and easily now and see how high the water really does get when precipitation is at its highest. Really what we have figured out is topography is the main influencer of the river's form, function, and stream discharge. We see that as it gets steeper, as topography gets bigger, we get more discharge, bigger, more water going through at one time, whereas when it's flatter and the gradient is lower, we get a slower discharge, we get slower moving water, and less sediment being brought out. And that is why topography, as much as many things do affect stream discharge and water movement, topography is the leading factor of stream discharge and why it is moving as fast as it does in some spots. So we can see that just by looking at the surroundings of the creek, we can learn a lot about why it is and moves the way it does. This is the Pacific Ocean where Douglas Creek lets out. Beautiful, eh? I'm Phillips and I've been your host today.